A ludicrous precedent by doing all these videos and staying here way later than my wife wants me to. So it's 10 o'clock at night and I am just getting started on homework, so not too much far different from you, the student. This is homework number 9. That's a Beatles reference, by the way. We have this wooden beam loaded up by ropes arranged by UHart students. The plate at the base, is held in place by 2 bolts. The plate doesn't touch the concrete, only the bolts anchor it. The bolts carry any horizontal load evenly. In other words, the horizontal load is divided equally between them. The dimensions and force values are 0.5 feet in between the 2 bolts, 2.5 feet, 2.5 feet, and 2.5 feet. And we have these forces right here. FC is 200, FD is 150, and FE is 350, and this is 30 degrees. We're going to find the equivalent force couple at a point between these bolts A and B, and then find the equivalent load in each bolt A and B due to the loading shown. Answer using a vector for each bolt expressed with I and J vectors, unit vectors. Okay, so here we go. Let me move this over to the side so I could read it and write it out. So here I am, rock you like a hurricane. It's the Scorpions. S21, ES110, and we are homework number 9. One of these days I'm going to play Revolution number 9 during class, in some class, because when I refer to it, no one knows what I'm talking about, because it is an obscure Beatles thing. Not obscure, it's just on the White Album, and I guess they had some studio time to mess around, and they got a little weird, and they just started making a bunch of noises, and they recorded it. But for one reason, it's got this weird, just announcer guy's voice, and he goes, number 9, number 9, number 9. And there's backmasking too, so that's something that everybody was afraid of back in the day, about the sounds of people making, oh, he's talking to the devil or something, I don't know. It was weird. It was a weird time to be alive. F.E. But I mean, the Beatles, that actually predates me, the White Album. I don't think I was born when the White Album came out. It was I was born 1970, and the White Album is got to be 68 or something like that. We could look it up, but we have other things to do. We're making all these things up right here, right? So here's Y, A, C. This is A, and this is A, and this is B. And the distance between these 2 bolts is going to be XAB. It's hard to read that, isn't it? XAB. And this is the 3, 4, 5 triangle right here. 3, 4, 5. And this is D. And this is C. And this is E. And these distances, something like that. Kind of got close. This is Y, D, E. And this is Y, C, D. And this is Y. I wrote it over to the side. Let's see. I already wrote it. I got interfering with my arrowheads are interfering with each other. There's AC. Okay, so our given, we're told a bunch of things. We're told a whole ton of things. We've got XAB is 0.5 feet. We'll say that YAC is equal to YCD is equal to YDE is equal to 2.5 feet. We're told that FC is equal to 200 pounds. We'll see that, where did FD is equal to 150. And FE is equal to 300. I'm very, very, very tired. And theta is equal to 30 degrees. And we want to find the equivalent force couple at between A and B, and then B, we want to find the equivalent bolt loads. All right, so how do we want to do this? Well, I think I don't know if I want to draw a diagram as part of this right here. I don't know if I like these couple questions as part of this because they I don't know, they're interesting. It does, the thing that I like about it is we could go to the bolts right here, but I would actually do this in the sum of the moments, kind of thing. That's how I would approach. I'm all about the free body diagram, but let's keep going on with this. We'll say with the moment is going to be about this. And I'm going to call it point O right there. So we're going to say the moment about O is let's just write the thing out. All right, so I'm going to say it's negative 300 times the cosine of 30 degrees times 2.5 plus 2.5. I could have just wrote times 3 times 2.5. Boom. All right, and then we could say this, but it's going to be plus our 150, but it's only going to be the 4/5 of that, right? And then it's going to be 2.5 plus 2.5, boom. And then minus, or maybe I'll put the minus next to the thingy down below right here because I had to keep going, minus our 200, but that's going to be down to 2.5. I could almost have fitted back over there. So I am going to find this force couple thing. This couple thing is going to be, I'd rather do this as the sum of the moments, by the way. And this, I guess this is kind of the sum of the moments, but 300 times 30 cosine times 75 times. All right, so then that's going to be negative. And 150 times 4 divided by 5 times 50, and then add that there, and then we're going to have 200 times 2.5 and subtract that out. So that seems like it's too much to me. So I must have messed up. 300 times 75, boom, times the cosine of 30, boom. All right, so that seems like, okay, so we got 150 times 4 divided by 5 times 50, boom, add it to it. Okay, and then this one, it just seems like too little. 200 times 2.5. Oh, no, we got to subtract it. That was supposed to be subtracted. All right, so I did get the 13,990. These are foot-pounds. And now we also want to get the resultant on here that happens on there. So we're going to say that, I don't know, we could write this in a bunch of different ways. I don't know if I like the way that I'm writing it right now, but I'll start out with the thing. We'll say that it's negative 300 times the cosine of 30 degrees. And, nope, not negative. It's positive, dummy. Positive, right? So there, it's going to the right up there, okay? And then minus 150, 4/5 of 150, and then plus 200 I, and then we're going to go 300, still 300 times the sine of 30, and then plus 150, but we're going to go 3/5, and that's J. So the resultant from all of this is an exciting 330 cosine times 150 divided by 5 times 4, no kidding. We're going to subtract that out, and then lastly 200 and add it together. And so we get 339.8 I plus 330 sine times that's 150, and then 150 divided by 5 times 3, 90? Yeah, it's 90. Okay, and we're add them together. So you get 240 right there, right? So 240 J, and these are pounds. So now what we want to do, so that right there is what we're going to have for A, right? We're going to say these two things, and maybe we'll even put a K in there, right? So that thing's about K. So like if we wanted to express it, that would be enough for us. It's a clockwise force. It's a clockwise thing right there, so that's why it's negative. But now we want the equivalent force couple right here. What we need to do is to turn this into a couple that is all right here. So the force at, so let's bring it all over to the force at A right there, okay? So, yeah, so what we have to do in order to move it over to the force at A, so this was at O, but now we want to move it over to A. So in order to move that couple, we have to move this force as well, right? And so the one in the horizontal direction is not going to do anything, but this one in the vertical direction will do an itty bitty amount. We could almost neglect it, but we won't. So we're going to take it and say that the moment about A instead is going to be equal to the moment at O plus what's going to happen when we move the thing over, right? So this is what this is going to look like right here. We're going to have a force that's like this right here. Right here, here's going to be my Rx, and here's my Ry, and then there's going to be this moment, MO. But we want to have that moment and move this thing over to A, which is going to be actually move over 0.25 over to be able to move it over. So by moving this thing over, what we're doing is we're taking a force and coming down, and then making a force and coming up right there, right? So we've created, by moving it over here, we've created a couple that is also going clockwise. So we're going to just say over here in the y direction times that x AB over 2. I don't know a better way to write this thing out. I'm doing this stupid couple thing right here. I don't know if there's, it doesn't seem as systematic to me. So we'll say that it's negative 13,990 right here. But it's also, maybe I'll make it minus right here. So it's also minus my 240 times my 0.5 over 2, right? So what I'm left with right there, if I'm going to do this, and I'm not sure anybody's going to get this the right way, but that's okay. We'll cross that bridge when we get to it, right? 0.25 times there, so it doesn't change it a whole lot. You see right here. So we're going to say that it's 13,990, and so we're going to have a negative 14,050 foot-pounds. Okay. And so now what we want to do here, in order to, so now that it's about A, right, that's going to be, now we're going to take a couple. Let's find the couple. All right, so the couple, I don't know what symbol to use right here, that's going to be equivalent to this is made up, so the couple is made up of 14,050 divided by our 0.5 feet right there, right? So that would be made up of the couples. Ooh, wait, sorry. All right, so this is a 15-minute thing. So 0.5 divided through there. So we have 28,010, I guess, pounds, right? Made up of two forces. I wrote the word two with T-O. Two forces of this right here, right? So one of them is coming upwards right here at A. And that's going to be the 28,100 pounds. Where the other is going to be downwards at 28,100 minus my 240, right? So it doesn't really, that's not really going to matter a whole lot right here, that 240. So 240 minus, so we're going to go, that's 27,860. Whoops. Keyboard's in the way. There you go. And then also at the same time, we have a force that's coming right here, which is the 339.8 divided by 2, right? So we have that, so that comes out to 169.9 pounds in both places, 169.9 pounds, right? So the answers to this wonderful thing, I gotta see what the people are going to say right here. So to part A, we have MO equal to a negative 13,990 foot-pounds. Oh, I want to make it a K. I made it. There you go. Foot-pounds. R at O is equal to 339.8 I plus R 240 J pounds. And a B, I'm going to say that we're going to have a R, it's called A at A and R at B. This is going to be a positive 169.9 I plus a 28,100 J, and this is going to be 169.9 I plus a negative 27,860 J pounds. And I almost want to take a look and see what the original was going to be. Let me take a peek. Really tired because I just made like some seriously stupid mistakes. All right, so I like when multiplying this up, I added these together as like 25s right in there. So wee doggy, let's fix all that nonsense right in there. So that was wrong, that was wrong, this was wrong, this was wrong. Oh, wow. That was wrong. This was wrong. Wrong. So that's going to be wrong. So this is going to be wrong. So that's wrong. So I'm glad I didn't stop the thing, even though it's 10:31 at night. 300 times 30 cosine, boom, and 7.5, boom, and that's negative. And 150 times 4 divided by 5 divided by, and then multiplied by 5. Boom. So that's 600. Add it to that. And then 200, and then 2.5, and multiply, but we subtract. So we get 1,849. That makes a lot more sense. So if we had 1,849 right here, and then but now we want to extend that over, so we go 240 times 0.25, right? And we get there. Okay, so now it's going to be 1,909. And so take that 1,909, and so this is the moment of this thing. But now we want to turn it just into a force couple system. So we divide it by 0.5. So we're going to have 3,817 pounds on each. So 3,817 would be like this one right here. But that's like the motion from over here. But now we have to go over to this side. Is that true? No. Over here, this is going to add onto the thing, right? So it's going to subtract from the thing. So 3,817 pounds, and then this one is going to subtract by my upwards one, right? 240, I think. So this is one is going to be 81849, and then this one is going to be 3577. What a mess. And then this one I think is going to be a negative 3817. So sorry about that. I got another problem to do.